Okay, then came the classical ML era, where basically I think some of you would have definitely heard these terms. So I'll keep on looking into question answers windows in few minutes, but I will also covering up the concepts. So basically focus on algorithms like, so then came in 1990s and to 2010, there was more focus on to statistical learning, where we focus on algorithms like SVN, descent trees. So just, so basically, if I just try to explain them in a simple language, basically these algorithms basically do a prediction. So prediction like, example, email is spam or not spam. Then there came things like Bayes models, which is little different from the prediction algorithms. It is basically do a probabilistic decision. What does it mean? How likely an email is spam or not. These models basically predicted whether the email is spam or not. Bayes model basically predicted how likely an email is spam or not. Then basically came, there was also a lot of ensemble learning. Ensemble learning is a simple term. If I try to explain it to people, is basically I am doing a voting. So let's say there are hundreds of weaker models and there's a layer on top of it. So I send the image to all 100 models. All of them predict whether the image is of cat or not. Finally, I sum out the output, and the summing might be again based on weight also. And then based on that, I take a decision and give an output whether the image is of cat or not. So basically, it's a kind of election happening between models, and finally, I'm able to predict something. So ensemble model basically is, you can say, it's ensemble of multiple models. And basically, libraries like scikit-learn and these things basically helped out ML developers to do the things fastly. And data was mostly structured and limited compute. That is a real problem. Why the deep learning or other things were there? I'm not saying not there, but they were not in that limelight as they are today. The problem was data was mostly structured, limited compute. The problem with ML is, one of the biggest problems with ML is so basically what happens in the big data world is you can do horizontal computing. You can spool multiple small machines and do the computing across the machines. But in ML world, when you train the things, you require a big machine. So basically, limited compute was another big problem with these models. And then basically by 2012, we were able to come into more into RNNs and CNNs. So basically a big breakthrough came up from the AlexNet, which basically beat all other models into image competition by a huge margin. It learned to recognize pictures like human do. Then basically CNN models are basically convolutional neural networks, which you can see they give eyes to your computers. Basically, computers can see images like you do. RN models are basically recurrent neural networks, help computers to understand voices like you do, or languages, LSTM like languages. Why it became possible? Because of GPU. So okay, what is CPU? How GPU is different from CPU? Anyone want to answer? What is the difference between GPU and CPU? Okay, let me answer. So basically, think the CPU is like a smart manager doing multiple tasks one by one. A smart manager doing multiple tasks one by one, doing many tasks one by one. On the other hand, GPU, originally made from gaming and graphics, but can handle thousands of tasks at once. So think it like an army of workers doing one big job together super fast. So in your 11, 12 classes, or not 11, 12, in your 6th or 7th standard, you would have done mathematical calculations like, if a person can do a field in 10 days, how much time it will take for 2% to do the field, and you did the mathematics and you came with an answer of 5 days. So similarly, think of GPU is a army of workers doing one big job together super fast. On the other hand, CPU, think it like a smart manager doing many tasks one by one. Okay, so GPU makes the processing extremely fast, because big process is basically big amount of work is getting done by multiple workers together. So that's gave a big compute power to these models, and that's how these models became successful and eventually upgraded to higher versions. And think of frameworks like TensorFlow or PyTorch are like your, in simple words, I would say Photoshop for images. So they basically, these tools give a lot of tools to create or handle ML code, but they don't have any logic inbuilt. So basically, they don't have any brain. Similar to Photoshop, you can do a lot of things to the image, but you have to apply your brain. You have to do those things. So that's how these tools help.